Luckily, there's a couple of easy ways to check most of these.
Okay.
Like I said, for the aperiodic one, the easiest check is if any state can communicate with itself.
Okay.
So any Markov chain, which has a state that can go from itself to itself, such that, I guess I'll write it out more explicitly. Any Markov chain where PII is greater than 0, for some I, it doesn't matter which I it is, that will always be an aperiodic Markov chain.
Okay.
That's the easiest way to check.
Okay.
Sometimes it's more complicated than that, but this is the, by far, easiest possible condition. And it's usually the case that there is some state that has this property.
Now, this is a sufficient condition for aperiodicity, but it's not a necessary. Is it a necessary condition?
It's not necessary.
It's not necessary. Okay.
You can have chains where you don't have any positive diagonals, but it's still aperiodic because of structures that pop up in other spots.
Right. And by the way, if anybody wondered what he meant by positive diagonals, if you write these probabilities out in a transition probability matrix, then the diagonal entries will be the ones where I is equal to I, right? So PII will be the diagonal probabilities in that transition probability matrix.
So essentially what you do is you look at whether or not there's any positive diagonal element to check this one.
In the transition probability matrix. Okay. Okay.